Right, you're most welcome. Today's session, we are going to be looking at sulfuric acid as a compound of sulfur. Sulfuric acid. You are aware from senior 1 to senior 2 chemistry, sulfuric acid has a formula H2SO4. And yeah, from knowledge of chemistry, we have sulfuric acid given as aqueous, and we have the same sulfuric acid given as a liquid. This morning, I want us to see conditions under which we manufacture sulfuric acid that it becomes aqueous and remains as a liquid. The syllabus requires that we describe manufacture of acid. This is done by process called contact process. Like we know, we shall begin by listing materials that we use, raw materials. Later on, we go into the technical details of the contact process. Sulfuric acid is going to come from majorly sulfur, but we must be aiming at converting sulfur to a certain compound which we all know as sulfur trioxide. It therefore means any student is capable of identifying the raw materials that we use in the manufacture of sulfuric acid. So how do we convert sulfur to sulfur trioxide? It must be a combination of sulfur and oxygen. Therefore, I'll need oxygen and sulfur as my raw materials to begin with, before other things can come in later. So from the chemistry that we have already covered, anybody in this classroom can tell us how can convert sulfur to sulfur trioxide. A series of steps involved. The question may begin from sulfur. The question may begin from a step away from sulfur. My dear students, one thing is clear. I want us to convert sulfur after utilizing oxygen to obtain a product that you know. And this product is going to be no product other than sulfur dioxide. And therefore, it means there is a technical term we are using here. We shall not use react. We shall not use the word combines. What shall we use? The word burn. So we must burn sulfur in oxygen to form sulfur dioxide. One good thing with this subtopic is that when they ask a question about it, it's easier for you to get all the marks. So I expect everybody to be armed with the necessary equation for the reaction. Therefore, sulfur, a solid, and oxygen, a gas. If you burn the two, you obtain sulfur dioxide, which is a gas. In the senior one, what did you say? Sulfur burns in oxygen with a blue flame to form a colorless gas, sulfur dioxide, which is an acidic gas. This reaction is one step. So I can begin manufacture sulfuric acid from sulfur dioxide. I can begin manufacture sulfuric acid from sulfur. If I begin from sulfur, we burn sulfur in oxygen, excess oxygen, to form sulfur dioxide. What happens this reaction gives out a lot of heat. Now, without stopping, we now get the sulfur dioxide with the minimum delay. We shall have our sulfur dioxide is further oxidized in excess air. So what shall we form now? We shall form sulfur trioxide. You have already noticed, or we have already looked at this scenario, that this reaction is a reaction that proceeds in both directions. I'm expecting this reaction to take place. So, in our usual style, now the sulfur dioxide, which is a gas, more oxygen in air, which is a gas, what do we form? We shall form sulfur dioxide, which is a gas. I have changed my approach. Instead of using a single-headed arrow, I have now used a double-headed arrow, showing that the reaction proceeds in both directions, and in chemistry, we call this reaction a reversible reaction. So before we continue, for this reaction to take place, certain things must be fulfilled, which you refer to as the condition for the reaction. Ladies and gentlemen, this reaction is catalyzed. And therefore, the catalyst we are going to be using will be vanadium pentaoxide or vanadium 5 oxide as a catalyst. It requires that the temperature should be a temperature of around 450 degrees Celsius and relatively high pressure of about 250 atmospheres for the reaction to take place. If not, the reaction is going to be extremely very slow, and the amount of sulfur dioxide to be formed is going to be limiting. Remember, in industry, what do you want? You want to get as much products as possible in the shortest period of time. It's like on a party. You want to eat as much cake as possible in the shortest period of time. So what do? You move in front. Because if you are behind, the cake will delay. You're going to get to finish before it gets you. So you move in front next to the high table so that whoever is serving begins with you. So how many servers are there? Like 6 people. So those are 6 pieces of cake in the shortest period of time. When others are still blinking, they have not even had one, for you have already had 6 pieces. Conditions. So without this catalyst, the reaction can take place but very slow. The amount will be small. At this temperature is what we call an optimum temperature, the best temperature for the reaction to take place at that pressure. We shall discuss this reaction in the future if we are looking at what we call reversible reactions. How do we arrive at these conditions? I want to mention that this sulfur dioxide must be dry and must be pure, free from dust. It must be pure and free from dust. Otherwise, dust is capable of making the catalyst not to work. And the chemists will say the dust can poison the catalyst. It doesn't mean to drink poison and it dies, but it stops the catalyst from doing its work. How? You have done biology. A catalyst has what we call the active sites. So these active sites are supposed to be taken up by sulfur and oxygen in order to form sulfur dioxide. If dust is present, dust occupies those active sites. That when sulfur dioxide and oxygen come, they find the active sites already blocked. So they can't what? They can't access. So a reaction does not take what? Place. Just at home, today you're all at home. Do this experiment for me and you give me the results. You get the padlock, push dust inside the padlock and try to push in the key to open. If the padlock opens, then you'll be lucky. Why? The key will not enter because the active site is supposed to be occupied by the key will be occupied by dust. And therefore, the mechanism we say is denatured in chemistry. This tertiary structure is denatured, rendering the catalyst impossible or incapable of bringing the two reactants together to get the product. So that's why we take precautions against certain things. So this is what we obtain. When we check, our equation seems not to be balanced from our usual style of doing things. So let us check and see. 1 sulfur atomicity, 1 sulfur. 4 oxygen, 3 oxygens. Therefore, using a fraction, it would mean this is a half. But if we want to use whole numbers, then I multiply the whole equation by 2. So that this one becomes a 2, this one becomes a 1, and we don't write it, and this one becomes a 2, becomes a balanced equation. This is step number 2. What is step number 3? Ladies and gentlemen, step number 3 involves converting sulfur trioxide to a certain compound which is called oleum. Converting sulfur trioxide to oleum. How is it done? It is done by adding sulfur trioxide obtained after cooling. After cooling, you add sulfuric acid, which is supposed to be some few drops of concentrated sulfuric acid, which is therefore a liquid. So what do we obtain? We shall obtain a compound which is called oleum. So if I had to use a chemical equation as required, sulfur trioxide is SO3, a gas, plus concentrated sulfuric acid is H2SO4, which is a liquid. What is the formula of oleum? The formula of oleum is H2S2O7, and it's a liquid. Therefore, if that's the product, there are limitations. If you are writing the equation, sulfuric acid can only be accepted as a liquid. However, if you put aqueous here, you may be accepted. But oleum must strictly be in the form of liquid. So whether you use aqueous or liquid, oleum must be in the form of a liquid. Without saying oleum is a liquid, you don't get that math. So that's the condition. So the acid must be concentrated to form that. It is possible, not, that when you get sulfur trioxide, a gas, and you add water to it, dissolve it in water, this reaction very readily takes place, spontaneously takes place, and will give you sulfuric acid, which is in the form of a liquid. Now one may ask, but honestly, why do you want to take me via oleum? Yet there is what that's going to give more readily than possible. This reaction has so many dangers. Number 1, this reaction is extremely exothermic. So exothermic. In chemistry, being so exothermic means gives out a lot of heat. Other than that, it also gives out what we call acid fumes in the form of spray, in the form of a fountain. And remember, sulfuric acid is very dangerous. So what's the effect of this? Number 1, it becomes dangerous to the person preparing. Acid corrodes. All the materials will be corroded. Number 2, it becomes a wasteful process. A lot of acid is lost. And at industrial level, this is not acceptable. In business, we don't accept wasting. So a lot of acid is wasted. Number 2, what about the fumes of acid that are being given out with a lot of heat? In the form of a pipe with pressure, and the pipe has been broken. Or you put your tip at the tap and open the tap and water is at pressure. What do you normally see? Water moving out in very high speed in the form of a fountain. That reaction takes place. And therefore, imagine you are the one in the plant where the acid is forming a spray. Imagine you are put in a room which is having fumes of sulfuric acid. And not the nature of sulfuric acid, what it does to human beings. Nobody can dare do that. So this means that this reaction is going to be dropped. For that matter, this reaction, dissolving sulfur trioxide in water, is not taken because, one, the reaction produces a lot of heat and fumes of sulfuric acid, which is wasteful and very dangerous. So we opt to this very quiet and humble method, and so on. So let us imagine you are moving on the streets and you are moving with the two people. When you meet you so and so begins to shout, hey, you see, I'm moving with so and so, shouting. Another room are going to move with quietly. I mean, for purpose of distance, being a lady, being a gentleman, you don't with somebody who is a little bit silent, and the one who is shouting all through, talking to everybody, that kind of thing, as if somebody is mad. So this one has a highest level of madness, dissolving it in water. This one has a lot of gentility, gentle lady, if it's there, gentleman style. Reaction is silent, and moreover gives a lot of products. There is no risk. So who doesn't want things that are polite and humble and good? So we shall choose dissolving the sulfur dioxide in sulfuric acid to form oleum, other than dissolving it in water to cause problems. So that is step number what? Number 3. So what is step number 4? Step number 4. Lastly, your oleum is now diluted. We shall say with a calculated amount of water. Calculated amount of water. Calculated amount of water to form concentrated sulfuric acid. So using an equation, I have H2S2O7. I said the liquid must be what? Liquid. Plus a few droplets calculated amount of water, physical state, liquid. So what do we obtain? We are obtaining sulfuric acid H2SO4, which is supposed to also be what? A liquid. However, if you add too much water, the acid can be given as aqueous. So in my discussion, I pointed out what can be accepted as aqueous. We can only accept aqueous if you are adding water, which is too much. This acid being formed can be taken as a liquid or aqueous. So if at all you used liquid here, this is supposed to be liquid, and this is supposed to be liquid, this is supposed to be liquid, this is supposed to be liquid. If you use the aqueous here, this one remains liquid, this one remains liquid, this one can accept liquid or aqueous. Those are the conditions. The equation is not balanced. How many hydrogens? 2 plus 2 giving us 4. These ones are only 2. Atomicity. Things are not matching. 2 sulfur. There is 1 sulfur. A total of 7 plus 1, 8 oxygens. A total of only 4 oxygens. So what do? We need to multiply this equation by this formula by 2. Such that hydrogens change to 4, sulfurs change to 2, and oxygens change to 8. By doing this, sulfuric acid has been manufactured. So let us look at the following. The question says, with the aid of equations, explain how sulfuric acid is manufactured. Explain how sulfuric acid is manufactured using equations only. Using equations only. So what do? So this is a summary. If the question says using equations only, describe how sulfuric acid is manufactured from sulfur. What do? Sulfur, solid, plus oxygen, gas. What we obtain? Sulfur dioxide. This is gas. Number 2, sulfur dioxide gas plus oxygen gas reversibly with all those conditions, sulfur trioxide, a gas. And remember, we balance the equation like that. So we say this is V2O5, 450 degrees, 250 atmospheres. We measured nothing. So what will follow next here? The sulfur trioxide gas plus H2SO4 liquid. What do we obtain? H2S2O7 liquid. Without mentioning anything, what follows next? H2S2O7 liquid plus water, a liquid. What do we obtain? 2 moles of H2SO4 liquid. You have explained how sulfuric acid is manufactured using equations only. When the question has not said using equations only, what do I want to see? I want to see the equations and I want to see the words. There are certain things you're not seeing here that could have been mentioned. For example, number 1, that sulfur burns. And this one must be what? Excess oxygen to form sulfur dioxide. So the word sulfur dioxide must appear. And the sulfur dioxide has what? 2 words, followed by the equation. So what do you do during revision? You just convert these equations into 2 words and write the equations also too. So sulfur burns in excess air to form sulfur dioxide. Full stop. Equation. The sulfur dioxide is oxidized in more air, or sulfur dioxide reacts with more oxygen at 450 degrees, 250 atmospheres, over vanadium pentaoxide as a catalyst to form sulfur trioxide. So what are we marking? Further oxidized, excess oxygen, name of the catalyst, correct spelling, quoting pressure, quoting temperature, name of the product being formed sulfur trioxide, correct spelling, 2 words, another mark. But you should have mentioned prior that the sulfur dioxide before to react must be what? Dried and purified to avoid poisoning the catalyst. We don't see it here. So what happens next? The sulfur trioxide is cooled. We don't see cooling here. And dissolved in concentrated sulfuric acid to form oleum. I don't see the name oleum here, but there I must see it, correct spelling and mark it. So what do I mark here? Cooling sulfur trioxide dissolve in sulfuric acid to form oleum. Those are about 4 marking points plus the equation. What happens next? The oleum is dissolved. I mark a dissolved. Calculated amount of water to form sulfuric acid. I may not mark sulfuric acid now because it's what has been asked. And the equation. So that is it. But during revision, I may not write the sentences. I write that. The way you saw ammonia, what was ammonia? Nitrogen and hydrogen in a ratio of 1 to 3 to form ammonia over which catalyst? Iron catalyst or platinum or asbestos, with temperature 450, pressure of about 2 atmospheres to form ammonia. By which process? Haber process. Yeah. Okay. Now ammonia is burnt in excess air using which catalyst? Platinum, to form nitrogen monoxide. Nitrogen monoxide oxidizes in excess air to form nitrogen dioxide. What did we say next? Nitrogen dioxide, after cooling, dissolved in water in the presence of excess air to form nitric acid. So contact process, Haber process are very friendly questions which students get as many marks from them as possible. Actually, students get even 15 out of 15 because there is nothing hidden in the Haber process. There is nothing hidden in the contact process. There is no technical interpretation wanted. Questions are as direct as possible, and so on. So this one summarizes the contact process. I'll ask that after today's lesson, sometimes we use what we call what? We use a reaction scheme. We use a reaction scheme where you draw boxes and arrows. You shouldn't get lost. So if this is something coming in, and I'm saying this is a combustion what? Combustion chamber. And I pointed out that this one is sulfur being brought in. So what is this one? Oxygen. What comes out of this, you must know. And therefore, you go into another chamber. So what is in this chamber? There is again air being supplied in, more oxygen coming in. And this is what we're going to call a catalytic what? Chamber. So this is the catalytic, where you know there must be that one and those conditions. So what comes out of this, you know it. And whatever is coming out of this goes into another chamber. You are adding in sulfuric acid. And this is called absorption chamber, absorption. So you must not is taking place. So what comes out of this? Something is added in. So what's going to be added in? Water. So what is this one? Is called dilution chamber. So what's going to come out of this? Should be concentrated sulfuric acid. So it's a matter of me now putting certain things here to confuse you. Catalytic chamber, I don't mention it. Combustion chamber, I say this is X. Then this is Y. Then I can even call this one Z. Alright? Then I call this one what? W, Z. And I ask you to identify X, Y, Z, W. Identify them. Explain what's happening. And so on. So what is X? X must be sulfur what? Dioxide. So what is Y? So Y can be name, identify. So you cannot name temperature. So name Y. So Y must be V2 or what? 5. So what is Z? Z must be SO3. Absorption, what is coming out must be H2, S2 or 7. What's this one? Must be concentrated sulfuric acid. You can't get lost with this reaction chamber. This can be in the form of a flow chart. However complicated you want to put it, you should remain focused. So I can pick the flow chart from this point and ignore this. I can begin with the sulfur, ask you a few questions about sulfur. Then I say, I explain how sulfur is converted to sulfuric acid. You should continue to produce the results. I can pick the question from here. How is sulfuric acid converted to sulfuric acid? Having asked you a few questions about preparation of this, describe how sulfur dioxide is prepared. Pure dry sample of sulfur dioxide is prepared. That dioxide is prepared in the lab. You talk about sulfur, prepare, coagulate by this. Now, explain how sulfur dioxide above can be converted to sulfuric acid. You don't begin from sulfur. You begin from here. So the sulfur dioxide is further oxidized by excess air over this to obtain sulfur trioxide. The sulfur trioxide is cooled and absorbed in sulfuric acid. This is sulfuric acid. To form what? To form oleum. And you continue with the flow chart and get what you want. I am asking all of you, when the lesson has ended, you go to YouTube, you type in contact process. They'll give you videos of the contact process. You may not see inside the factory. They'll be showing buildings, this kind of thing taking place. And some of them will give you this flow chart, which is showing how things are moving in. There are various types of the YouTube videos on contact process. Please, you view them, reinforce your understanding of what is taking place here. And it's very possible. There are several. You can even click about three. Three videos are enough. One that shows the general house, general factory where sulfuric acid is being manufactured and the steps being involved. Others are using flow chart like this, but you see what is happening in the flow chart and so on and so forth. So you choose which one is okay for you. You view it. If you want, you download. You can review. You can revisit that kind of thing. This is how good these things are of late. That you just mention people, Mr. Google, sir, bring a contract, they bring. Mr. Google, sir, show them what happens. If you want to write notes, they also even give you notes to write, depending on what you want. They even ask you, what exactly do you want? Do you want the explanation? Do you want the notes? Do you want the technical details? Don't look for technical details of log and the key hypothesis here. Absorption, don't look at them because we are not interested in the technical details. So that one summarizes sulfuric acid formation. We don't prepare it in the lab, but we can prepare it on a large scale. But we can have theory that can lead to its preparation in the lab. There we are, we have the manufactured sulfuric acid. We are supposed to be venturing into the properties of sulfuric acid. I want to say for today, there are three properties of sulfuric acid. There are three properties of sulfuric acid. Number one, it is sulfuric acid as an acid. What makes to be an acid? Number two, we have sulfuric acid as an oxidizing agent. Number three, we must have sulfuric acid as a dehydrating agent. Some of these things we have met them, some of them we have not met them at all. I am sure about number one, and I'm going to take a very short period of time to communicate about number one, because we already know it in detail. When is sulfuric acid an acid? Sulfuric acid is regarded as an acid when it is dilute. When it is dilute, that's when it is an acid. So define an acid in senior one, a substance which when dissolved in water produces hydrogen ions as positive ions. Therefore, sulfuric acid, for it to be an acid, must be dilute. And when dilute, what does it mean? It is in water. That's when you see the word AQ, aqueous, means in solution in water. That is when it can ionize completely and donate hydrogen ions in solution mixed with sulfate ions in solution. My question as for now is it a strong acid? Is it a weak acid? It is a strong acid because undergoing complete what? Ionization to produce hydrogen ions as the only positively charged ions. Is it a monobasic? dibasic, tribasic, tetrabasic acid. It is a dibasic acid because it's giving out two hydrogen ions as positive ions. Therefore, when dilute, sulfuric acid is a dibasic acid. And I want to add the word and say it is a strong dibasic acid, where there are two things covered here. Number one, what does it mean to be strong? Complete ionization. Number two, why does it qualify to be dibasic? Two hydrogen ions. Number three, why are we saying an acid dissolved in water? Because it can easily ionize. So it is not your first time, neither is it my first time, nor a second to all of us to meet an acid and properties of acids. I want to say it is easy to talk to the converted because I never heard God's word other than preaching to the one who is coming from the shrine. So I'm not talking to people who are coming from the shrine. I'm talking to believers who have already been taught by the religious leaders the characteristics of what? Acids. This time we are being so specific. Remember the other day we looked at nitric acid. What did we form? Nitrate. This time what are we going to look at? Sulfate. So being an acid, we endeavor to find out that its reactions, what do they produce? Produces metal sulfates. Metal sulfates as what? As salts. Maybe with water, maybe with hydrogen or carbon dioxide. So what do? My dear ladies and gentlemen, we revisit the chemistry of senior 1. Number 1, sulfuric acid with metals. Number 2, sulfuric acid with metal oxides. Number 3, sulfuric acid as an acid with metal hydroxides. Those two are called bases. Oxides and hydroxides are called what? Bases. Number 4, its reaction with carbonates, metal carbonates, and its reaction with the metal hydrogen carbonates. As an acid, that's how we know acids. Meaning blue litmus turns to red. So what do you remember? A metal with sulfuric acid. This time is sulfuric acid. So plus sulfuric acid. So what shall we get? We are going to get here a metal sulfate. What else will be given out? Hydrogen gas. Now you can fit it and write the equation depending on the metal, and you get the answer right and balanced. Now I say this is now simple because I'm talking to the converted who already know the word of God. So what will happen? Plus sulfuric acid, plus sulfuric acid, plus sulfuric acid, plus sulfuric acid. All of them will give us metal sulfates. So metal sulfate, metal sulfate, metal sulfate. The other one, these two, will give us nothing other than water. And these two, we shall add something. We shall add all of this, but we shall also add what? Carbon dioxide gas. Now, does it mean every metal oxide, every metal hydroxide, every metal carbonate reacts to sulfuric acid? No. Except which metal? Except lead and calcium. And maybe barium. All other metals will react. And maybe copper. The reason for lead, calcium, and barium is not the same reason for copper. What's the reason for lead, calcium, and barium? Insoluble sulfate. Stop the reaction. What's the reason for not reacting with the copper as a metal? It is lower than sulfur or hydrogen. It's lower than hydrogen. Copper is lower than hydrogen. Cannot displace it. So dilute. Therefore, which oxides are we kicking out? We are kicking out if oxides. The oxide shall kick out will be 3 oxides only. So we are kicking out lead oxide, we are kicking out calcium oxide, and we are kicking out barium oxide. Copper oxide reacts when heated. It's basic enough. Hydroxides will be the same. PbOH 2, CaOH 2, and BaOH 2. No reaction. Same reason, insoluble sulfate. And so are carbonates. So lead carbonate cannot react. Calcium carbonate cannot react. Barium carbonate cannot react. All hydroxides may not also react for the same reason. So the question I'm setting right now is, why can't we prepare carbon dioxide from calcium carbonate dilute sulfuric acid? Why can't we prepare carbon dioxide from dilute sulfuric acid and calcium carbonate? Because of formation of the insoluble coating of what? Calcium sulfate. The reaction cannot take place. So this will not react to give you calcium sulfate and carbon dioxide, what it refuses, because you shall form a coating of calcium sulfate that stops the reaction from further taking place. So this information, we already know it. So we can pick out 1, 2 examples, just 1, 2 examples, and we see what's going to happen as an acid. I'll pick one metal oxide, one metal hydroxide, one metal carbonate. So let me pick out a metal, for example, if I pick on magnesium to represent all metals. So magnesium plus sulfuric acid, aqueous, what do we obtain? We shall obtain magnesium sulfate, aqueous, plus hydrogen. The equation is balanced, representing the metals. Let us pick a metal oxide, and we see at least one metal oxide. At least one metal oxide. Maybe if I picked on group 2, group 1, if I picked on, say, sodium oxide, a solid, and I add the sulfuric acid, it must be aqueous. Liquid becomes wrong. What do we obtain? Sodium sulfate, Na2SO4. This is aqueous. What else will be formed? It will be water. This equation is representing all metal oxides. You can pick a hydroxide. At least one hydroxide of your own choice. And a hydroxide. I can even pick, say, calcium hydroxide, no. Magnesium hydroxide, maybe. Barium hydroxide, no. Lead hydroxide, no. So think of any hydroxide. Maybe it could be potassium hydroxide. Aqueous. You said plus sulfuric acid. Aqueous. So what do we form? We shall form potassium sulfate, which is aqueous plus water only. The equation is balanced by putting a 2 here. I shall not go into details of balancing the equation. You can pick one carbonate, at least one carbonate, to represent the family of carbonates. Let us pick zinc carbonate, even if it's copper carbonate. So if we picked one colored one, copper 2 carbonate, a solid, plus sulfuric acid, aqueous, what do we obtain? Copper 2 sulfate, aqueous, plus carbon dioxide, a gas, plus water, a liquid. So that one summarizes reaction of sulfuric acid as an acid. Made in senior 1, made in senior 2, made in senior 3, and nitric acid, and hydrochloric acid, and finally under sulfuric acid. So there is nothing new. Here we are repeating ourselves. So that property of being an acid as an acid is covered. But when dilute, all right, allow ourselves venture into property of sulfuric acid as an oxidizing agent. So when do we use sulfuric acid as an acid? When dilute and it is at room temperature. When do we use sulfuric acid as an oxidizing agent? This only takes place when the acid is concentrated and it is hot. When the acid is concentrated and hot. We discussed this reaction using, we use copper. This time the acid is concentrated, doesn't react with the cold dilute, but reacts with the hot concentrated. We can go ahead and use oxidizing agent. We can use carbon. We can use sulfur, another oxidizing agent. Hydrogen what? Hydrogen sulfide gas. But I want these three first. And maybe others as oxalic acid. Do you have the notes of oxalic acid? So what's the formula for oxalic acid? H2 C2O4. Those are the 5 possible reactions. Of the 5 possible reactions, these 3 are very common. Then followed by these 2. So if you get copper and react it with concentrated sulfuric acid hot, we insist this must be strictly what? L. So what do we obtain? We shall obtain copper sulfate. So the product is copper 2 sulfate aqueous. It gives sulfur dioxide, a gas, and gives out water as a liquid. This explains as to why most of you give this reaction as a method of preparing sulfur dioxide. We don't accept this as a method of preparing sulfur dioxide. We accept it as a property of sulfuric acid as an oxidizing agent, but it's not a laboratory method of preparing sulfur dioxide. I want to repeat. These reactions looked at as a property of concentrated sulfuric acid, but not as a method of preparing sulfur dioxide in the lab. And teacher demonstrated, full stop, on the teacher shows. It involves heating concentrated sulfuric acid, which can jump out of the test tube, and the repercussions can be many. So our equation is not balancing. We attempt to balance. Copper works out. Sulfur is a big problem. We have 1 sulfur, we have 2 sulfurs there. It's not working out. So that will force me to first try a 2 here. Let me first try a 2 here, and I see if it will work. If I try a 2 there, hydrogen have switched to how many? To 4. And therefore, I will need a 2 here. Sulfur works out. So we shall count oxygens and see. If there are 8, we continue. How many oxygens are these? 8. These are how many? 4. Plus 2, 6. Plus 2, 8. That is the balanced equation for reaction. So, copper can only react with sulfuric acid if sulfuric acid is concentrated and hot. as an oxidizing agent. Copper cannot react to dilute sulfuric acid even if it's hot because copper is below hydrogen. It cannot displace it. What about the reaction with carbon? Carbon and a concentrated sulfuric acid, a liquid. What does it give? It will give us two gases. It will give us carbon dioxide as a gas. It also gives sulfur dioxide as a gas. It also gives out water. Since the solution is hot, it will not allow sulfur dioxide to dissolve in water to form sulfurous acid. It drives the sulfur dioxide out, balancing the equation. Oxygens here, carbon is 1, 1. Hydrogens are 2, 2, they work out. Sulfur is 1. Oxygens are 4. Here, oxygens are 5. What do? We do something. So 1 has not helped us. Therefore, the next number to try is going to be a 2. When you try a 2, hydrogens have switched to how many? To 4. So I'll put a 2 here. Sulfur has switched to how many? To 2. So I'll try a 2 here. Now check the oxygens. Oxygens are 4 times 2, they are 8. Let us check the oxygens here. These oxygens are 2 plus this how many? 4. Those are 6 plus 2, 8. So it means the equation is now balanced. I can use this relationship to predict the third equation. Wherever there is oxidation, as if we shall need 2 moles of sulfuric acid. Let us see. Sulfuric acid, when heated with the powdered sulfur, what does it give us? It's going to give us sulfur dioxide. And what else do we expect? We expect strictly water to be formed. Hydrogens work out. Sulfurs are not working out. Here there are 2. The other side is only 1. Oxygens are 4. These are 3. So what do? Maybe like our usual style of trying things. If we try a 2 here, hydrogens are 4. This is a 2. Sulfurs are how many? 2 times 1 is 2 plus 1, 3. So I put a 3 here. Oxygens are 8. 2 times 4, 8. 3 times 2, 6 plus 2, 8. Sulfur dioxide is a gas, and this is a liquid. So am I right to predict that okay, 2 moles, and sometimes we ask the students to find the whole memorizing that. So when they ask preparation of sulfuric acid, one of these questions comes in. And one of the other questions that are going to come in. So somebody knows whatever it takes. If sulfur dioxide, water. If carbon dioxide, sulfur dioxide, and water. 2, 2, 2, 2, 2, 2. If copper sulfate, sulfur dioxide, and water. 2, 2, 2, 2. The equation is balanced. Try out sulfuric acid with hydrogen sulfide, oxidizing agent. What's oxidation? Addition of what? Oxygen. So who gets oxygen now? So what will be the product here? It will be sulfur. Somebody is saying sulfur. What else? Somebody is saying sulfur dioxide, and water. Let us see if it will work out. Or shall we get only sulfur dioxide and water? 4 plus sulfur. If you try out that one, I can see 1 sulfur there. I can see 2 sulfurs are there. Hydrogens are 4. Oxygens. So it's possible. Sulfur dioxide, and water. It's also possible that in the presence of this, you might get up with sulfur only and the water being formed. So if we get sulfur only and the water, if this gas gets lost and gets dissolved, so what do you expect? Is it possible we can dissolve this one and we get only sulfur plus water? If sulfur plus water, sulfurs are 2 hydrogens, does it work out? It doesn't work out even if you try to what level? So I want to say this is a 2. So it doesn't give you sulfur and water. So pick out that one. Some other person said, but it can give me sulfur dioxide plus water. So if sulfur dioxide plus water, we have seen 2 sulfurs. They are there. I'm seeing now hydrogens are how many? Are 4. This is a 2. When you check, how many oxygens do we have here? 4. How many oxygens are these? There are 6. This is 4 plus 2, 6. These are 4. So, settle for this one very quickly. And we continue. So what has happened? Hydrogen sulfide has been oxidized to water and sulfur dioxide. Sulfuric acid is reduced to sulfur. This one comes from sulfuric acid. This one comes from this and that. So here, sulfuric acid reduced to sulfur, while hydrogen sulfide is oxidized to water and sulfur dioxide. Oxalic acid and sulfuric acid. We need to cover this in senior 2 because the syllabus expresses that we must prepare carbon dioxide, not carbon what? Monoxide. So this reaction and sulfuric acid will give us carbon dioxide. It will give us carbon monoxide. What else can it give us? Carbon dioxide, carbon monoxide. What are we expecting? We're expecting what? Sulfur. What else do you expect? Maybe water in the system. So carbon works out. Hydrogens are 4. So I'll put a 2 here. If so, oxygens are 8. These are how many? The cheapest could even be methanoic acid, HCOOH plus sulfuric acid. So the same carbon monoxide, carbon dioxide, sulfur dioxide, sulfur plus water. So you're trying to balance. After balance, what have you got? Where do we put a 6 where? A 2 where? A 3 where? Since you have been reading and asked to comfortably read. So check out on that. If that one doesn't work out for you, can you get carbon dioxide? Being an oxidizing agent plus water. So this is a 2. That is a 2. So think of the product along with this line quickly and we'll continue. So carbon dioxide, sulfur dioxide, and water. So carbon monoxide is oxidized to carbon dioxide. So the cheapest equation here we are coming up with is this reaction. This is plus sulfuric acid liquid giving us carbon dioxide, sulfur dioxide, and the water. Hydrogens are 4, I'll put a 2 here. Carbons are 2, I'll put a 2 here. Oxygens are 8, these are 4, 6 plus 2, 8. In this reaction, sulfuric acid is acting as an oxidizing agent. What are the conditions? Concentrated and hot. I want you to capture of all reactions, capture this reaction, capture that reaction, and capture that reaction. They are quite important. And briefly, we made this one under the property of hydrogen sulfide. Briefly, and we left it. So these are the two, but these three, please, they must be at your fingertips. These three: copper, carbon, and sulfur. So that one is as an oxidizing agent. We are left with the sulfuric acid as a dehydrating agent. So dehydrating. The word dehydrate, to dehydrate, what does it mean? To remove water. So sulfuric acid can remove water. It can remove water. This explains as why I use it as a drying agent. Why it is a drying agent? It removes water. So in chemistry we say it removes elements of water from a substance. To remove elements of water. So what are the elements of water? Hydrogen and oxygen, which the two combine and give off water. So it removes the elements of water. It explains as to why we use it as a drying agent to dry what? Gases. This reaction is limited to a few possible processes that I expect all of my students to know. Number one, I expect my students to know a reaction as a dehydrating agent with hydrated copper 2 sulfate. And so is the reaction with hydrated cobalt 2 chloride as a first reaction. Second reaction must be a reaction as a dehydrating agent with ethanol and other alcohols. Propanol could be one of them. We don't go beyond that. Number three, my students might discuss the reaction of copper with starch and elements of starch, which may mean sucrose, maltose, glucose, dehydrating properties. So if you can filter out the three, then you're through with the chemistry of sulfuric acid. Remember in the question, when asked about sulfuric acid, what follows next are questions on the properties of sulfuric acid. You don't go to somewhere else. We can't take you into quantitative analysis. No. Properties of sulfuric acid. What is the color of hydrated copper 2 sulfate? Hydrated copper 2 sulfate is blue. What's the color of copper 2 sulfate having removed the water? The blue substance turns to white. And we say dehydration has taken place. If I'm to use an equation, the equation is as follows. Copper 2 sulfate has about 5 molecules of water of crystallization, which is a blue solid. The moment you put concentrated sulfuric acid into copper 2 sulfate, it changes to copper 2 sulfate, remains a solid, but these 5 elements of water will have been removed and be part of the acid. So the acid concentration changes. So this one we know from our chemistry is blue, and this one I know it is white. So what is white copper 2 sulfate? White copper 2 sulfate is anhydrous, meaning without water. So this one is anhydrous. If it's anhydrous, It changed from hydrated. So what has happened? It means water has been removed. And who has done it? Concentrated sulfuric acid. Observation, changes from blue to white. Explain. Elements of water have been removed. The hydrated salt has become anhydrous. The equation is reversible. If you brought water and added, what happens? It goes back to blue. So when you add elements of water, it goes back. This one of the reaction we use to describe physical changes in the chemistry of senior 1. Cobalt 2 chloride, that's the same. So cobalt 2 chloride has about 6 moles of water of crystallization, solid. When you put sulfuric acid, what does it change to? It will change to cobalt 2 chloride, a solid. But 6 elements of water will have been removed by the acid. So what is this? This is also hydrated, and this one is anhydrous. What's the color here? The color is pink. What's the color here? Blue. So what happens? The blue crystalline substance turns to, pink crystalline substance turns to a blue, sometimes looks like a powder, blue powder. Why? Water will have been removed by sulfuric acid. If I want to go back to blue, to pink, what do? I add water. That's why in quantitative analysis, how do we test for water? We test for water using anhydrous white copper 2 sulfate that turns to blue, or use anhydrous cobalt 2 chloride that turns from blue to pink to prove that the element you have added is water. So qualitative analysis, check out for these two in the qualitative analysis. So that one is summarized. For this matter, therefore, we use copper 2 and we use concentrated sulfuric acid as a drying agent to remove water from substances that are hydrated to become anhydrous. Explain how a dry sample of is prepared. What do you say? Pass the gas through concentrated sulfuric acid. Why? To dry it. Why? Does not react. But what is it? Dry. Remove water. And indeed, sulfuric acid can remove water. Indeed, it can remove water. I'll find out from the discussion if there is access to the lab, through the office. Maybe some of the things can be seen because they can easily be done, and so on. Ethanol. State conditions under which ethanol reacts with sulfuric acid. Ethanol and propanol. You covered organic chemistry. State the conditions under which ethanol is going to react with sulfuric acid. The acid must be concentrated and the acid must be hot. Which temperature? 170 to 180. So what happens? Ethanol will have water and propanol will have water being what? Removed. So what do you end up with? You end up with an alkene, and elements of water will be removed. So do you remember ethanol? Yes. What was the formula for ethanol? C2H5OH. In the presence of concentrated sulfuric acid at a specific temperature of 170 degrees Celsius, what do you obtain? A C2H4. What has been removed? Hydrogen and oxygen. How many hydrogens? 2. How many oxygens? 1. And those two combined in a ratio of 2 to 1 to give you water. This is given off as a gas will accept a liquid, and that is a gas. Yeah, it is. If it is propanol, prop means 3. Therefore, the formula is going to be C3H7OH. Same conditions, we shall get C3H6. What has been removed? elements of water. This compound, the first one, is a compound we are calling ethene. The second compound is being called propene. Therefore, what are we concluding? Alcohols are converted to alkenes when treated with the concentrated sulfuric acid, because concentrated sulfuric acid removes elements of water from the alcohol, changing them from single bonds to double bonds. And we did this when introducing the chemistry of alkenes, preparation of ethane from ethanol. All these reactions teacher-based because of the danger of sulfuric acid. So there is no way you can run away from this equation. It is not possible. It is not possible because it's going to come back as organic chemistry. You can't run away from it. Of all the hydration reactions, you capture that one first. Yeah, these ones of removing water from hydrated substances can come last. But capture this one first because most likely it is this one. So what's the second opportunity? The second opportunity with glucose, with starch, with maltose, any form of sugar, whether the sugar is white, whether the sugar is brown, whether the sugar is which color, mix of white and brown, it doesn't matter. Anything called sugar, even flour for posho, even if it's flour for what? For chapati, even if it's rice, even if it's matoke, whichever form of carbohydrate. The syllabus requires that our students should know the formula of glucose. So I'll use glucose. But it can be sucrose. It can be starch. It's biology that allows you to know the formula of starch. Chemistry does not allow you to know the formula of starch, but they allow you to know the formula of glucose, which is C6H12O6. Glucose must be in a solid state. Don't say, after sports, they should have given me to take it. No, we can also waste it by putting concentrated sulfuric acid to it. What happens? Glucose changes to carbon, charcoal, and will end up losing all the elements of water. How many moles of carbon are this? 6. Hydrogens are 12. This is a 6. Check the oxygens are 6. So this reaction produces a lot of heat. A lot of heat that water is lost as water vapor at very high temperature. And carbon is in the form of a sponge. It forms a spongy black mass. Spongy black mass involves the process of what? Swelling. So you see the mass rising because of formation of air space is a spongy kind of material. Therefore, brown sugar or white sugar turns into a black spongy mass accompanied by evolution of too much heat, and the water is lost as water vapor. You can't touch the beaker using your bare hands. You can't. I promise. Even if you say you know how to cook and hold hot saucepans from gas cookers, you can't at least try this one. It's too hot. But if you know the formula of sugar, so we had on the word sugar, all of them are sugars. But if you want to sucrose, the formula for sucrose is C12H22O11. I can continue and bring it to starch if you so wish. So the same, this is in the form of glucose. This in the form of maltose, in the form of sucrose. It can be in the form of lactose. It can be in the form of galactose. All of these in biology are forms of disaccharides. 2 molecules of this coming together. And therefore, whichever dehydration are going to take place, same conditions using concentrated sulfuric acid, you'll end up with carbon plus water. So what do I put here? A 12. What do I put here? 11. and this is a gas. Too much heat being produced. Well, say, if they have given you starch, which is not most likely, what's the formula for starch? I think starch is something with C6, H10, I think O, something with O5. Something like that. So you have to dehydrate this one. So what will you obtain? 6 moles of carbon plus 2 moles of 5 moles of what? 5 moles of what? Of water. Whichever form. So don't waste a lot of time on the formula of starch. But you can take this one, you can take that one. Even cellulose. What is cellulose? Are our cellulose in the form of lignified starch? Even a table like this one has cellulose in it. This table is made up of nothing other than starch. You wonder why termites survive on wood. You think they are mad. They are not mad. They have an enzyme that can break this cellulose into starch. Hydrolysis takes place until they get glucose. Don't wonder why termites eat peppers. Don't wonder why cockroaches can survive in a room where there is no food. What do they eat? They eat wood and papers. They eat wood and clothes. Where there is no food, cockroaches bite clothes and the papers and the books. You get into a bookshelf, see how many cockroaches are available, and no food has ever crossed the library. Why? They are busy eating the paper which is made up of starch. Get a piece of paper, put it in water, boil it in water, these ordinary papers, boil them in water, then add iodine. You will prove that there is a lot of starch in these papers. So is your piece of cloth. If you think it is a lie, in school when you come back and have access to concentrated sulfuric acid, we shall get concentrated sulfuric acid and pour on any student's breast, whether a male or a female, we don't care, as long as you're a student. And we shall see what's going to happen. The piece of cloth readily burns and turns into a black substance, which is form of soot and so on. But you have seen as to why people are capable of burning others with sulfuric acid. What do? They just pour. However little it is gets into contact with the face, the part of the face in contact with sulfuric acid turns into charcoal and falls off, black porous mass. If you look at a person who has just been burnt by sulfuric acid, you see nothing other than charcoal, porous with so many holes, and of course that part of the body is already gone. That's why even plastic surgery is very difficult. Why? Sulfuric acid, if it can look for water in a dry piece of paper, it can look for water available in you. What about your blood cells that have a lot of water? Much of our body is more than 60% water. People who have done chemistry, dry ratio, biomass, something like that, I don't remember quite very well. But that kind of thing. So since the body cells have a lot of water, they easily get dehydrated by turning the mass of a substance, the body of a substance, into carbon. I remember a scenario when I was just in senior 1 in my secondary school, so many years ago. One student was told that ringworm can be cured using an acid. Because the boy had a lot of ringworm, they said, just apply acid. The person who gave the boy the information not to specify what acid, which concentration. And it's true, ringworm is a fungi. It can be treated using acid. Ringworm thrives on sugars so much from the body. So they like a neutral medium. When you introduce the acid, the medium becomes unfavorable for them, and therefore they die. Why? I have been telling ladies why it is not good to bathe yourself in the reproductive organ, private parts, using soap, because soap neutralizes the acid. And if the environment becomes neutral, fungi easily grow. Therefore, you are capable of easily suffering from candidiasis and UTIs if you are using soap to bathe yourself. The environment is supposed to be acidic to avoid the growth of microorganisms like fungi. Ringworm is a fungal infection. Now, this child, after entering the lab, reached for a bottle which was written on acid. He did not write the name, but the name of the bottle was concentrated. And you know, in chemistry, we write using the symbols. We don't write in a food, they just wrote conc SO4 acid. The younger man carried the acid in a bottle, which had a loose cover, a glass topper, not like a bottle of soda. You can close it tightly and put in the pocket. After putting in the pocket, shortly after the lesson, of course, we could attend the rule in the lab. You don't sit, you remain standing. He contained. When the bell went for lunch, the boy ran to the DH. As he was trying to run to the DH, the bottle cover went off, and the man was seriously showered with sulfuric acid. It burnt the piece of trousers was putting on. It burnt his body, and you cannot the part of the body was burnt because the acid was put in the pocket of the trousers. Moreover, the front pocket. You know the repercussions. Now, trying to trace for cutting body parts, they couldn't be found. We found some that looked like charcoal, and we didn't know that that was the man's systems. Totally burnt and off in the form of charcoal. That's why I tell students, don't enter the lab when you are running. The idea of finding everything around to test is not good, because you can end up touching a concentrated acid, and I swear upon the living God, you leave your fingers in the container. You leave them in the lab, because sulfuric acid will burn you and turn you into carbon as it's looking for water. Dangerous acid. That's why people burn others using sulfuric acid. There is nothing you can do almost until the acid has done its part. And to make matters worse, you bring water and pour water, you make it more, because you are adding more. It's looking for water, and you are adding more water. So the way forward is you get burned until you are reaching the hospital, because only the hospital personnel, maybe like some of us, though are not hospital personnel, who know what you can give, what you can give, what you can add to a patient who is having an acid to neutralize it. So by the time they rush you to hospital, a lot of cells have been damaged. That's why cure, repair is very difficult, because you are excessively burnt towards the bone level. So tell me how you recover your shape, your face, the ID gone, spoiled, and so on. And you have seen them in large numbers. Please don't try this at home. It's dangerous. The acid will disorganize you thoroughly very well, and so on, as a dehydrating agent. Properties of sulfuric acid handled. What did we say? As an acid. Number 2, as a dehydrating agent. Number 3, as an oxidizing agent. And all that information in the notes, senior one work, organic chemistry, covered. It would be okay if people could think of a few uses of sulfuric acid. Uses of sulfuric acid. Number 1, for me, I'll give 3 for you to add the rest. Number 1, being an acid. Okay. All car batteries use sulfuric acid as the electrolyte. And this is how people access this acid, by the way. They go and buy it, pretend they're going to use it in the car batteries, or to go and burn others with it. Dangerous. So a battery cannot produce energy if it's a wet battery unless the electrolyte is sulfuric acid. Number 2, you all like using soap, detergents, and what, and so on. So soap, detergents, and paint are all manufactured from sulfuric acid. All from sulfuric acid, be it liquid soap, be it solid soap, because the process somehow involves addition of sodium hydroxide, which must be neutralized, and some of them you add sulfuric acid directly, especially detergents like Omo, Ariel, and so on. You manufacture them through strictly sulfuric acid. So cooking oil, fats, are mixed with concentrated sulfuric acid to form sulfates. And in your A-level chemistry, you'll be told sulfonation of the fat or oil means addition of concentrated sulfuric acid under heat. After that, neutralization by adding sodium hydroxide to form soap, detergent, which is a salt. So what is Omo? Omo is a sodium salt of sulfonic acid from sulfuric acid. Liquid soap is a sodium or potassium salt of something to do with oleic acid and so on. So they have brand names and we have brand names. We call them trade names that are being used. People who have been making liquid soap were making soap from what they call the sulfonic acid. So what is sulfonic acid? For us, we know what sulfonic acid by formula and so on and so forth. So that is it. Unger what sulfonic acid, all speak the same language. Number 3, there are so many things that we can use sulfuric acid for. Sulfuric acid can also be used in the manufacture of certain what? Fertilizers. For example, the cheapest fertilizer I can think of right now is ammonium what? Sulfate. Where does it come from? Ammonia and sulfuric acid. Potassium sulfate from potassium hydroxide. So most of the sulfates are also used as fertilizers. Any others of sulfuric acid? You can now add.
Alkenes.
So extraction of alkenes. We have seen that as a dehydration reaction. And you can add so many other uses of sulfuric acid. There are quite many. Add some other uses of sulfuric acid. So use the manufacture of other salts. Used in paints is captured here. And so on. So all the uses of sulfuric acid are quite enormous, as we have always discussed. Think of quite very many, but at least 4. We want only 1 or 2. These are about 4. And you have about 6, 8 of them. But of all, 1, car batteries, priority. Number 2, detergents, soap, paint. Number 3, fertilizers. These are things that are within our environment. And I think of very complicated things that we don't know. Nobody doesn't know a battery. Nobody doesn't use Omo, Ariel at home. Nobody doesn't know there is paint. Nobody doesn't know that fertilizers, ammonium salts are fertilizers. So for us in the lab, sulfate, if you pour it into the ground, if it's not radioactive and toxic, you have given plants what? Fertilizers. Though some of them are a little bit dangerous. So what are we left with in this topic? We are supposed to be looking at the salts of sulfuric what? Acid. Salts of sulfuric acid. I may not have time for interaction with people today, but it's going to generate as many questions as possible. I want to look at something else until I've handled this issue. Because our next interaction, we're going to be summarizing salts of sulfuric acid. Then I'll ask questions all the way from sulfuric acid up to the end. What are the salts of sulfuric acid? There are 2. We have what we call the soluble sulfates. You know that. Soluble sulfates. And you know them. And number 2, they are what? Insoluble sulfates. Anybody in this classroom has already seen this. What are the soluble sulfates? There are quite many. All of them except, so we can only mention the insoluble sulfates. What are the insoluble sulfates? Barium sulfate, very good. There is barium sulfate, lead 2 sulfate, and calcium sulfate. The rest of the sulfates are soluble and they can be used as good fertilizers, except these 2. These 2 are not good fertilizers. So why is lead sulfate not a good fertilizer? It doesn't release the sulfate ion since it is insoluble. So there is no you can get a nutrient that has been locked up and cannot be accessed. Now, I want to ask, did we prepare salts? Yes, We prepared the soluble salts and insoluble salts. So back to my scheme, nitrates. So what are we turning? Instead of nitric acid, we are putting what? Dilute sulfuric acid until in excess. Filter off the insoluble, excess what? Soluble. Get the bottle drive of excess water. Cool to obtain, restores. Filter, wash with some little cold distilled water, dry between the filter papers. You can see how that scheme developed one time. We just now seeing it. And we get the answers. What about barium sulfate? To barium nitrate solution, add an equal volume and concentration of dilute sulfuric acid. Start for complete reaction. What do we do next? Filter. What do we do next? Wash with excess water. What do we do? Spread it to dry. Now we are through. Wonderful. As I told you, talking to the converted is a good thing. So what is left? What we shall ponder on as we close our sessions on sulfur is effect of heat. But you already know from qualitative analysis, when you heat sulfates, what do they give you? You are aware that when you heat sulfur, what do they give? Mercury sulfur what? Trioxide. And the metal ends up forming a metal what? Oxide. What's the effect of sulfur trioxide? You have covered sulfur trioxide. It is an acidic what? Gas. What does it do? Litmus paper to red. Are we there? It dissolves in order to form sulfurous acid. And what's left is a metal oxide. Colors of metal oxide we have already seen. If they are white, what does it mean? Yellow when hot and white on cooling, zinc oxide. From zinc, sulfate. Yellow when hot, orange when hot, yellow on cooling, lead sulfate, oxide from lead sulfate. But not very possible because it doesn't really decompose. So briefly, the chemistry of sulfates. So how do you confirm sulfates in the lab? Finally, what do we use to test for sulfates first? We said we use barium what? Lead what? Lead to what? Nitrate solution and nitric acid. In the quantitative analysis before we went home, what were we seeing? A white precipitate of lead to nitrate. How have we been confirming sulfates? We have been using acidified barium nitrate solution to form barium sulfate, seen as a white precipitate, and what has been our statement? Sulfate ion confirmed present. So, one good thing with chemistry of acids, hydrochloric acid, nitric acid, sulfuric acid, the chemistry remains the same. You delete one word, sulfate, replace it with the chloride. Delete chloride, put nitrate. But the chemistry remains typically the same. And we have done a lot about quantitative analysis of this sorts of sulfuric acid. I therefore want to call upon you to organize questions that we shall begin with in our next interaction before we go to the next topic. So get ready for our next topic in our discussion. Thank you for attending. God bless you. So now what are we going to do?